Welcome back to Jackson Square. Today we'll be starting Chapter 6, and our TEK is 6.10a, which says, I can model and solve one-variable, one-step equations and inequalities that represent problems including geometric shapes. So we're going to start with modeling, and this is very similar to our integers, so we are going to just go right into our key. And in our key, we see that if we have a yellow circle or a yellow square, it's a +1. If we have a red circle or a red square, it's a negative. If we have a long rectangle that's green, it's +x, or a red, it's -x. The rectangles and squares are called algebra tiles. So we use counters or integer chips before, and we're using algebra tiles now. You'll see me use both. Or we can even use a cup to represent our variable, our x, our y, our z, our a, our b, our e, whichever variable that we have. And we most of all don't want to forget that a zero pair is made up of a yellow and a red. They will equal 0, as well as if we have a positive green x and a negative red x, those will equal 0 as well. So for our first problem, we have 9 equals x plus 8. Please do not be afraid of this because the 9 is on the left side and not on the right side. It doesn't matter. They're equivalent. So the x can be on either side. It's not a problem, okay? If it bothers you, you can move the 9 over to the other side if you just need to see it the right way, but I don't want you to be afraid because you see it differently. So just like with integers, this is a +9, so we're going to start by modeling 9 counters or algebra tiles. And on my other side, I have an x plus 8. So I'm going to grab a green x, that's my positive, and I need a +8. So what I'm going to do to make this a little bit quicker is I'm just going to copy my 9 from this side. Hopefully they copy. And drag them over here. Oh, they didn't come. Undo. Let's try that again. Okay. Yes. So it worked in 3, 4, 5, 6, 7, 8. I just copied 8. Perfect. So now I have my x plus 8 on this side. Well, we want to get x alone. The whole objective of equations are to isolate and solve for the variable. Say it with me. Isolate and solve for the variable. Isolate and solve for the variable. Isolate and solve for the variable. Isolate means to be alone. X just wants to be alone. He wants to be all by himself. So on this right side, we have to get rid of whatever is bothering X. So right now, X is not alone on the right side. There are 8 yellow counters there with X, and they need to hit the road, Jack. And don't you come back no more. They need to get out of there. So to get rid of those +8 counters, we have to do the inverse operation. And I hope you remember the inverse property says if you add my opposite to me, I will be 0. So to get rid of these yellow counters, we have to add 8 red counters on that side to get rid of them. So I'm going to add my 8 red counters, and they are going to the back. So I'm going to bring them to the front. And I'm just going to lay them on top of the yellow. Okay. So to get rid of those, I have to, I still kind of want to see my yellow. Okay, so to get rid of those, I have to add 8 negative. Well, when we talk about an equation is like a balance beam. It's like a scale. It needs to be balanced. If I do something to this side, then this side is off. So whatever I do to one side, I have to do to the other side to keep it balanced. So if I added 8 negative over here, I need to add 8 negative on the other side to keep it balanced. So I'm going to add 8 to the other side, and I'm going to try my trick again of copying these and then dragging them over here so I don't have to do all that work. And it works. Woo, woo. All right, so I have balance. I have restored balance to my equation. Okay, so again, we remember that a yellow and a red makes a zero pair. So all of these are basically zero, like they don't even exist. And if you wanted to, you could go through and like swipe them out, and then you would see that you'd be left with just this X over here. I'm just going to leave them on top of each other, letting me know that they're zeroed out. Same thing over here. I created 0 pairs. So as you can see, the only thing that's left without a partner is that yellow square. So that lets me know that X, the value of X is 1. Okay, the value of X is 1. So not only are we going to model, we're also going to be doing the steps numerically as well. So I'm going to drag those up and show you how that will look. So in this one, I did reverse the problem just for comfort's sake, and I put X plus 8 equals 9. So the first thing I want you guys to do every time you get a problem like this is you are going to draw a dotted line right down the middle, because we need to show those two sides, the left side and the right side, so that we can remember to keep it balanced. So just like before, X wants to be alone, isolate and solve the variable. So to get rid of, we need to get rid of that positive 8. To do that, you're going to do the opposite, which is subtract 8 from both sides. So this is the same thing we did with the counters, with the tiles, just doing it numerically. So I subtract 8 from both sides. Then I draw my line because I need to do some simplifying. Okay, so then positive 8 and a negative 8, that zeroes out. I bring down my X. Okay, bring down my X. Let me see if I can add an arrow in here. Okay, I bring down my X. You're also going to bring down that equal sign, okay? So you're going to bring down that equal sign. And then 8 combined with a negative, 9 combined with a negative 8 is 1. So X equals 1. So this is our numerical number work and our model, and we can see that they look alike, okay? Let's try another one. So here we have X minus 4 equals negative 3. This time we're going to use cups and counters, and that's always fun just because it's something different, right? So for X, we're going to represent it with a cup. For negative 4, grab 4 red counters. And on the other side, we have negative 3, so I'm going to do 3 red counters. Remember, the goal of an equation is to isolate and solve for the variable. Isolate and solve for the variable. Isolate and solve for the variable. Ooh, X wants to be alone. Who is on the left side with X? Negative 4. We need to get rid of negative 4. He needs to get out of there, hit the road. So we're going to do the inverse. The inverse of a negative 4 is a positive 4. So we're going to add positive 4 to this side to cancel him out. I'm going to add that, and you start to see that we are creating those 0 pairs, right? So we're creating those 0 pairs. So that cup is going to be by itself. That X is going to be alone. But remember, we have to keep balance. So I've just made this side heavier by adding 4, and this side is lighter, but we have to keep that balance. So whatever I do to one side, I have to do to the other. So I'm going to have to add 4 counters on this side so that we have our balance. So now balance has been restored to our equation. We can go in and eliminate those 0 pairs. So these are gone. X is alone. On this side, we are eliminate 0 pairs, and we are left with a positive 1. again. So we have x is equal to 1. So that is our model. I just happen to randomly pick these two models and they both equal 1. X will not always be 1, so does not believe that. That was just random. Let's do the numerical part. So if our problem is x minus 4 is equal to negative 3, remember we're going to draw that dotted line. Draw that dotted line down the middle. That shows our two sides that we want to keep balanced, okay? And I know these problems are easy. You can do them in your head. It's not about you being able to solve for x at this point. It's you being able to follow the logical steps in the process. So I know you don't want to write it down, but please do your teacher a favor and write it down, because these steps are going to be so important in like 2 days from now when we're doing two-step equations. You have to know that first step, that second step. So you're practicing now to get ready for the bigger problems. So go ahead, draw that dotted line, add 4 to both sides, draw your line, summarize everything. Do it for me, okay? Not that I know you know the answer, but do it for me, okay? Do it for me and it'll make life easier for you, I promise, okay? So we're going to do the inverse again, which is adding. Okay, what's easier? Maybe it's just easier for me to move the dotted line. Okay, so we're going to do the inverse again, and we're going to add 4 to both sides. We have to keep that balance. And then once we do that, we are going to summarize. So we're going to draw a line underneath. Positive 4 and a negative 4 will be 0. We're going to bring down our x, and I can draw an arrow again. We're going to bring down our x here. Just bring it straight down. That's not a straight arrow. Pretend my arrow is straight. Okay, so we're going to bring our x down. We're going to bring the equal sign down, and we're going to combine a positive 4 and a negative 3 to get a positive 1. So what I want you guys to do is pause, and practice. And you're going to practice x plus 1 is 3 and show your work. X minus 3 is 5, show your work. And then for those who are ready for that challenge, 2x equals 8. Pause, practice, get back with me. Welcome back. So hopefully you guys enjoyed this. This was fun. We jumped in and you guys started practicing with x plus 1. As you can see, with my model, I had my x, my positive 3, and my positive 1. I had to do the inverse and subtract 3 from both sides. These canceled out. I was left with x. On this side, 1 canceled out. I was left with negative 2. Here at the top, you see my work where I subtracted 3 from both sides. Remember, I put my dotted line to show my two sides. I did my line to simplify. That was for my subtraction and addition, and x equals negative 2. Here we had x minus 3 equals 5. Here's my x, my negative 3. Here's my positive 5 on this side. To do the inverse, the opposite of negative 3 is a positive 3. So I added 3 to both sides. I ended up with x is equal to a positive 8. This side we had no 0 pairs, okay? Here again, we had x minus 3 equals 5. Draw my dotted line. I added 3 to both sides, okay? The 3's cancel out, and I'm left with x is equal to 8. And last but not least, if you guys went for the challenge, you put your 2 cups here, you put your 8 counters there, and then there's nothing to subtract. There's nothing to add. Remember, a number next to a variable means multiplication. So what's the inverse of multiplication? The opposite of multiplication is division. So what I had to do was take those 8 counters and I had to divide them among the 2 cups. And I said, 1 for you, 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 1 for you. And then when I ended up, 1 cup had 4 counters. So 1 cup, remember, equals x, our variable, our unknown. So the value of x is for positive 4. Okay, so this is a multiplication one-step problem. So hopefully you guys were able to figure it out. Maybe it stumped you, maybe it challenged you. Hopefully it was one or the other. So how does it look? It looks, and I noticed I did not put my dotted line. Oh, Miss Jackson. I'm sorry, Miss Jackson. Ooh. Okay, so I need to go back here and tweak some things. And I need to put my dotted line and show my two sides. Yes, yes. Okay, so I have 2x is equal to 8. Then the opposite of multiplication is division. So what I did was I divided both sides by 2. Please notice this is a fraction bar on both sides. It's not the same as when I do the simplification bar all the way across. This is 2 separate bars. Please notice that. Some kids just see the bar and then they get confused and they subtract 2 from 8 and get 6 instead of dividing. This is a division bar. You are dividing 8 by 2. So 2 divided by 2, I don't know why this 2 is negative. Okay, 2 divided by 2 is 1. So I'm left with a 1x. But remember, the 1 is invisible, so you don't see it. You just see the x. And then 8 divided by 2 is